You just watched the volume video, right? Tell me you watched the volume video. Okay, good. Let's do temperature then. Bam, temperature. Okay, so I've heard about temperature before. I know temperature is like when something's hot or cold, so I'm just thinking of that. Now I'm going to read this. Okay, so it says temperature is a physical quantity which gives us an idea of how hot, I just said that, an object, or cold an object is. The temperature of an object depends on the kinetic energy. Okay, I remember kinetic energy is energy from movement. I remember this from a previous reading. Okay, so it depends on the kinetic energy of the object's particles. Interesting. As an object is cooled, the speed of its atoms and molecules slow down, and it loses kinetic energy. Okay, I want to capture that. So, cooling means slow particles means less kinetic energy. Okay, interesting. So it says, for example, as water cools, the slowing vibrations of the molecules allow the water to freeze into ice. I know ice has very little random molecular motion. So they've got to slow down to become ice. That makes sense. In all materials, a point is eventually reached at which all oscillations, okay, I know an oscillation is just a vibration. Oscillation is just a vibration. Okay, vibration are the slowest they can possibly be and have essentially stopped. The particles have no energy. The temperature which corresponds to this point is called absolute zero because it is the lowest temperature possible. Okay, that sounds important seeing as they took half the paragraph. So absolute zero, the lowest temperature possible, no energy. Cool. Alright, what does this diagram show? So this diagram, we got different things. We got Fahrenheit, we got Celsius, we got kelvins. I see water boils, water freezes. So freezes, boils. I see absolute zero. I see Kelvin has it at 0K. Celsius is negative 273. And then Fahrenheit is negative 459. I think this is really interesting that Kelvin has 0K, whereas 0C is when water freezes. What else am I noticing? Let's see, there's a 100 gap between freezing and water boiling for Celsius, and there is for Kelvin too. Except here, Kelvin just has absolute zero at 0K. I may return to this later. I'm not sure. I'm going to keep reading. Whoa. There's a unicorn and I don't even know. Okay, that was weird. So let's keep reading. Scientists use two temperature scales. Okay, the Celsius scale was divided by Anders Celsius, so I guess one of these is Celsius, seeing as they're talking about it. He used the temperatures at which water freezes and boils to establish his scale, because these temperatures are easy to reproduce. So, easy to find, basically, to do again. He defined the freezing point as 0C and the boiling point as 100C. Okay, so let's capture that. Okay, so freezing, that's too many E's, equals 0 degrees C, and then boiling equals 100 degrees C. Okie doke. Then he divided the distance between these points into 100 equal units, or degrees, units, Celsius, okay? And then it says the Kelvin scale, that must be the other one. So Celsius and Kelvin. The Kelvin scale was devised by a Scottish physicist and mathematician, William Thomson, who was also known as Lord Kelvin. Now that would be a cool name, Lord Kelvin. A Kelvin, K, is the SI base unit. I'm not really sure what SI means, but I know base is like basic unit of temperature. This scale uses the same temperature steps. So, steps. I'll come back to that. As the Celsius scale, but is shifted downward. On this scale, water freezes at 273 K and boils at 373 K. Okay, steps. So here there's still 100 between this, right? Just like there's 100 between this. But here it's 273K and 373K. So it's higher. So I'm going to add to this now. This could be 0C or 273K, and then boiling could be 100 degrees C or 373K. Okay. Nifty. Alright. Only on the Kelvin temperature scale does absolute 0 fall at 0K. The Kelvin scale is an absolute temperature scale. So I guess absolute temperature scale means 0K is actually 0 temperature. 0 temp, 0K, I guess. The relationship between the Kelvin and Celsius scales can be described with the equation below. So K equals degrees C plus 273. Okay, if I return to this, well, not that, this, again, I see everything that I've just captured in the paragraph, I see in this diagram, right? There's this 100 difference. Absolute 0 is 0K or 273C. I didn't see any mention of Fahrenheit. I guess that's not one of the scales they use, so I'm just going to ignore it now. I don't know. Okay, what else? Okay, I've got these examples now. So I guess I can do some math with this equation, right? Because I know the equation is K equals degrees C plus 273. So if I'm converting from degrees Celsius to Kelvin, it says the melting point of mercury is negative 39 degrees C. So I have K equals, I just plug in, this is the degrees C, and then add 273, and I get my answer 234K. Okay, that makes sense. And it says converting from Kelvin to degrees Celsius, it says the boiling point of mercury is 630K. So now I plug in for K, I'm looking for degrees C. I need to get this by itself, so I subtract 273 by both sides. This cancels out. I get 630 minus 273, and I get 357 degrees C. Okay, let's see if I can do this again. Let's see if I have, okay, 0K, that's absolute 0, right? What would that be in Celsius? Okay, so I can plug that in. I know 0K equals degrees C, which is what I'm looking for, plus 273. So now to get degrees C by itself, I'm going to subtract 273 by both sides. This cancels. So I have degrees C equals 0 minus 273, so negative 273 degrees C. So this is also absolute 0. It's just in a different temperature scale. It's using Celsius and not Kelvin. Interesting. Bam! 2 down, 1 to go, pressure. Look at the next video. Yes.